Good evening to everyone around the globe today, where we want to welcome you to today's Link webinar. My name is Margot Newcomb. I am a Director of Marketing Communications for Teledyne Marine, and I'm here to kick off today's presentation with you. So before we get started, though, I do have a couple of quick housekeeping items. The first is today's presentation will be recorded. I know we're often asked that. You will receive an email with a link to the recording within 24 to 48 hours. So just watch for that, and you should see that coming through. That applies to people that registered and were not able to attend as well. So if you have colleagues that registered and couldn't make it, they will get a recording. Also, due to a large number of attendees, we have registered today. Everyone is muted. However, we do encourage you to type in and submit any questions as we go along, and we'll be more than happy to address those at the end. So with that behind us, I'm very pleased to introduce today's speaker, Bryan DeLeon. Bryan serves as our North American Sales Manager for our Cable Solutions Group. As you know, Teledyne has acquired a number of, well, as you may know, you may not necessarily know that, but Teledyne has acquired a number of our industry's leading interconnect and cable brands over the years, and included in that is Teledyne Storm Cable and Teledyne VariSystems. These organizations now work collaboratively as Teledyne Marine Cable Solutions, and they supply engineered solutions for challenging cable situations. That is their wheelhouse. So today, Bryan is going to walk you through some of their multifaceted solutions and the considerations that you're going to want to bear in mind when you're designing your cable and cable assemblies. So without further ado, I'm going to go ahead and turn things over to Bryan. Bryan, it's all yours.
Thank you for everybody. Appreciate y'all's time coming in. I know everybody's time is valuable nowadays. Today, we're going to really cover Teledyne Cable Solutions, as well as capabilities, but really get down into the meat of cable design, cable assembly design, things to look for. Before we get into that, we are a HSE company, so everything we do really revolves around making sure we're safe, making sure the environment is safe. So our HSE safety moment today is making sure, as far as ergonomics, if you're sitting at your keyboard or if you're sitting at your desk looking at your computer screen for long periods of time, make sure to get up, stretch. If you're doing a lot of typing, try to get a ergonomic keyboard and mouse to help with any kind of long-term issues. So one thing is stretching can be highly beneficial in preventing ergonomic injuries. So again, stretch things. If your legs get tired from sitting, get up, massage them, and then really kind of stand up and exercise. Okay. Today's objectives, again, Teledyne Cable Solutions. We want you to understand who we are and what we're capable of. So we're going to do some capabilities review. Then we're going to really get into the meat of the presentation, which is really things to know prior to designing a cable or cable assemblies. Some design criteria considerations, really where to start, connectors or cable. Also, we're going to review some cable components, mold designs, mold types, get into some regulation awareness, and then have a Q&A at the end of the presentation. Okay, Teledyne Cable Solutions. We comprise really three product lines, three verticals. One of them is cable, custom cable. So we can manufacture a variety of different just bulk raw cables. We also mold, so we can do any type of mold types that you would need on the cable, and then we also manufacture connectors. We've got, again, three product lines: Storm Cable, VariSystems, and Impulse. That's going to be comprised of cable, molding, and then connectors. We've got 4 facilities that we manufacture out of. That's Dallas, Texas, San Diego, California, Calgary in Canada, and then we've got a Tijuana facility that we manufacture. So one of the important parts here is if there's any kind of issues in either one country, I know we ran into some NAFTA issues in the beginning and in the last year. We were able to really mitigate that problem because of the manufacturing flexibility that we do have. Our business focus really is custom core cable for harsh environments. It's also underwater and harsh environments for electrical connectors, and then molded interconnects utilizing our internal manufactured cable and connectors. So the going theme here are harsh environments. We really focus on being able to handle and mitigate the environments that you generally see in either underwater, real aggressive type environments. If you're in space, that's definitely a harsh environment. Some key markets that we've got that we really focus on: land, oil, and gas was one of the big ones. We generally dealt with Halliburton, Schlumberger, FMC. We also deal with the geophysical and subsea oil and gas market, which is more underwater based. We work heavily into the military and defense and security side of things. We also work with heavy construction equipment and medical equipment. So these would be the really 4 to 5 focus markets that we've got. Now we have a lot of offset markets like type inspection, tower lighting for airplane warning systems. So, but these would be the main focuses. And of these, as I mentioned, we work with Halliburton, Schlumberger for the land, oil, and gas, FMC for, and a few others for subsea. We work with Lockheed and Honeywell for the military and defense side of our business. We're working on the nuclear rearmament program. We're one of 3 companies that manufacture cable assemblies for that. We're also working on the new hypersonic missile program with Lockheed. We do some heavy construction with companies like Almond, and the medical equipment. Everybody's really familiar with the ventilators that we had a big deal about earlier in the year. We actually manufacture cable assemblies that go into the Air ventilator systems that have been distributed really pretty much all year. So to give you an idea. So as we mentioned, we manufacture cable, multi-core, and a variety of different gauge sizes, a variety of different constructions. Pretty much anything that I can get on a bobbin or a spool, I can manufacture into a cable. And then we also manufacture, we're one of the only companies that can manufacture all 4 molding type or molding capabilities that are in the industry. I'll get into a little bit more of this as we move into the molding and down towards the presentation. And then we manufacture connectors. So we already have the ability to, we have our own connectors, which are glass reinforced epoxy. Those are GRE connectors, rubber molded connectors, metal shell connectors. We have some miniature high densities connectors, as well as, again, your rubber molded style connectors. Now, we also manufacture some custom cables for companies like Honeywell. We manufacture a special 38999 that they use in the nuclear missiles. So we do have that capability as well. Okay, enough about us. Let's really talk about cable design, cable assembly design. So what we want to review here are just some things to know prior to actually doing the design. You want to kind of keep in mind, okay? First thing is, the more performance that you need out of the cable or that cable assembly, and the more reliability, the more the cost goes up. And that's just indicative of how products are. So as an example, if you need a 5-year life on a connector that you're going to be on an ROV that's going to be coming up to topside every day, you're looking at $30, $40 connectors on that. If it's going to be in a harsh environment where if you've got some downtime that could really be detrimental to the program, you may go to some metal shell connectors. They tend to get a little more pricey. If you're on a Christmas tree and you're down, they stay down for a while, you're probably looking at $50,000, $60,000, $70,000 for a connector, because the cost of pulling that piece of equipment up and out of commission is more expensive than it would be to spend for the higher dollar connector. So keep that in mind when designing. I bring this up specifically because you don't want to over design something. You want to be able to meet the requirements to help keep pricing in line with the program. Okay, a couple things that we want to be conscious of. Sole sourcing. I know everybody finds connectors, but really want to check the availability of other manufacturers with those connectors. Make sure that you're not just tied into one, or prevent as much as possible being tied into one connector source. This helps with availability, helps with price, keeps your lead times down. So when we design, we always try to find find a connector that other suppliers or is offered by multiple suppliers. Material capability or compatibility. So one of the things we'll get is polyethylene or Teflon connector. Well, you may not be able to mold to those type of materials, but you were in a high temp environment. So you want to make sure that the jacket materials or insulating materials are conducive to the application and what needs to happen with that cable or cable assembly. Another thing is specification compatibility. You want to look and make sure the cable, if it's a negative 50 degrees Celsius application that you need on that cable, that the connector will also meet that negative 50 degrees Celsius temperature range. So make sure that everything matches up. Also look at what your actual needs are versus your wanted needs, because the more you design a product, the more restrictions or more enhancements that you need from that, the more restrictive that design becomes. So you want to make sure you cover what your actual needs are, but you also don't want to over-design it to where it kind of pigeonholes you into certain materials that maybe are more expensive or more readily available. Generally, as a manufacturer, what we like to see is your baseline requirements to meet the program, and then if you have a secondary set of subsets that you're looking for that maybe not be a need but a want, we do want to hear about those, but we want to make sure we get you in good materials that will accommodate the actual needs first. Also, account for extra circuits. That's one thing. Wires aren't that expensive, so if you can account for an additional conductor or two, definitely want to incorporate that into the cable. So you get a down circuit and the program's commissioned, you need to, and you get a wire that breaks, you can easily switch either in the system, or you can change the bulkhead to be able to account for that break and utilize that additional circuit or wire that you've got in there. Okay, what I've got here is this is a engineering review and manufacturing process that we use internally. So the first four that I've got here are really applicable to any end user, and then what we also use, and then as we roll into the other four, that's really on an internal, but if you're manufacturing internally, these are some good pointers or a good process that we use. So the first and foremost, statement of work, right? What is the requirement? Generally, we'll have an application checklist that we follow through or that we go through to make sure we're covering all of the requirements, environmental requirements that may be needed. The next thing is the functional design specification. So what the product is designed to do. Does it need to meet 5,000 PSI? Are we going into a 200 degrees Celsius environment? So we need to make sure that we specify that. And then requirements verification, or basically we want to verify the materials that are going into this product meet the statement of work. So a lot of that can be done through manufacturing specifications, compound specifications, to make sure we are meeting and verifying that we're meeting the statement of work. The next thing is the design documentation. So generally, if you're coming to a manufacturer, you'll have your own specifications. So you want to be able to communicate or the design that you're putting together and provide that to the manufacturer. We'll do that internally as well. So as we work our way through the process, we'll come up with the design or basically the specification, we call it, to ensure that we've documented the statement of work. Then we'll have a design review. So as an end user, if you do your own design documentation, you would transition this to your engineers, your design team to review, to make sure that all parties internally or between your company and a manufacturer, there's agreement of the design and that statement of work. From there, if you're manufacturing internally, you'll have your manufacturing documents. To us, what we do is we actually manufacture data packets that go with every single cable or every single cable assembly job that we manufacture. It's verbally, it's documented verbally. It's also documented through pictures. We have a complete work instructions packet that goes with that. we've actually designed this to accommodate our government contractors, and it was so well documented, we just floated through our entire manufacturing process. So once you've got the manufacturing documents, get with the staff, verify the equipment to make sure that there's manufacturing conformance. Basically, you want to verify that the equipment can build what is needed. So as an example, if you've got a cable that needs to be 15,000 feet long, you want to make sure that your planetaries or your bunchers can handle that length of cable. So that's your verification process. And then on the very final step, you've got your quality check. So basically, check what was made, was agreed to. So that runs through a variety of different quality checks that can come from either the customer. Most or all manufacturers should have their own internal quality check. One thing you want to be careful here, or just be aware of, a manufacturer's quality checks may not match up with what your quality expectations are. So be sure to communicate those to the manufacturer. For cable, standard quality checks would be high pot, isolation resistance, things like that. But if you're wanting, say you've got a digital pair in there that needs to be 100 ohm impedance, you want to make sure you ask for testing for that impedance and report that with the overall quality package. Okay, design criteria considerations. So when designing a cable, there's a variety of different things that you want to be aware of or consider. So that'd be environmental considerations, chemical considerations, any kind of mechanical requirement considerations, electrical, and regulatory. So environmental. So what are we looking at? Is it going to be in the Mojave Desert? Are we going to be up in Antarctica? Are we going to be in a nuclear power plant? Are we going to be on an oil rig out in the middle of the Black Sea? These are all definite harsher environments than what you'd see in a factory. So we want to be aware of these. These are all going to require different type materials. As an example, if you're in Antarctica, you want a material that can really get down to negative 60 degrees Celsius. So you'd be looking at a TPR rubber. If you're in a nuclear power plant, you're going to be looking at Teflon and crossing polyethylene. So that's where the environment is really important on determining what kind of materials we're going to use. A chemical. So how corrosive is the material? Am I going to be in benzene or any kind of acid? You know, that again dictates the material it will be using. May use a polyethylene or may use a Teflon. If we're in jet fuel, we may end up using a Teflon or a rubber, depending on what kind of fuel, if it's JP10, JP8. We also sewage, oil, all these are indicative to what type of materials we will be using. Then we've got mechanical. So strumming. If I've got a tow cable, am I concerned about that? If I am, then I may need to look at hair fairings to go on the outer jacket. Is my assembly going to be load bearing? Am I looking at being able to pull up 1,500 pounds? If it is, then then my termination would be different. I wouldn't go with a standard cable with a Kevlar braid around it. I need to tie that off to something. Am I going to be in high pressure, 5,000 to 10,000 psi? I'll need to look at PVOS possibly. Then I also need to look at what kind of coaxes I would be using. Obviously, you can't use foamed coaxes in 5 to 10,000 psi. So those are all specific. You know, am I going to be on an elevator lift where I'll see continuous flexing of that cable or a rolling flex? The cable designs would be different for an application like that versus an application that requires to mitigate strumming. Okay, electrical. We need to know if there's anything in the construction that needs to have impedances, or are we concerned about crosstalk? What kind of power requirements do we have? Are we looking, high amperage? Are we needing anything that has balanced pairs? And additionally, what kind of shielding are we looking at? What kind of noise is going to be in that environment? If we're looking at a low hertz mechanical noise, we'd be looking at a braid shield. If I'm looking at higher frequency type noise, we'd go with foil shields. It's a combination. We'd use both. Okay, where do we start? Really, it's a chicken or the egg type question. a lot of the time connectors are already chosen. You can't really move from that. In that scenario, you're kind of stuck. So you design from the connector and you move to the cable. If you don't have the connector already chosen, it's preferable to start with the cable design. Reason why is being cable diameters can affect connector type. So once you identify the environment, what's needed material-wise to manufacture the cable, your jacket thickness may be larger than normal because of abrasion type resistances that you need. So you don't want to have a cable that's so large that it protrudes the profile of the connector. So that could be an issue. Also, cable constructions can affect the connector type. So if it's a load-bearing cable, there's only so many connectors that have a shaft on the back end of that connector that could be tied to handle that load. So you want to design the cable first because there's also 3 to 4 different types of ways, or 3 to 4 ways that you could integrate that Kevlar into the cable that could also affect the connector choice. Also, there's more flexibility in connectors and choices. So once you nail down that cable, we've got the flexibility to kind of look at the market and see how many connectors, or find a connector that better suits the cable as opposed to finding a connector that may be outside of the range of what that cable can handle. Also, cable is always the last thought, meaning generally connectors are readily available, depending on it, obviously if they're specialized, if you're looking at ODI connectors, they've got lead times. But in general, cable's the last thought. So they have a 6 to 8 week lead time. Sometimes they have a 10 to 13 week lead time. If you design the cable first, you could get that on order, get that 8 to 10 week, 10 to 12 week lead time process out of the way, or at least started, and then you can start working on the connector selection. So it just helps keep in line with the program and meeting deadlines. Okay, let's talk about plating. There's a lot of, we're going to address a couple of things regarding why plating is used and the types of plating. So bare copper in general over time oxidizes. When that oxidizes, what happens is you start getting your resistivity increases. You start getting reliability and connection issues over time. So generally, the wire will be plated to help either reduce, eliminate, or just prolong the oxidation process. Standard coatings are going to be tin coating, nickel coating, and silver coating. So on tin coating, that's going to be your general standard that most manufacturers use. What this does is facilitates rapid soldering and reduces the oxidation significantly. One thing I'd like to point out is there's generally get questions and concerns about if it affects the electricals, meaning if you're designing a pair that has impedance on it, will the tin copper affect that, or is there resistivity issues? There's not. Bare copper will perform the same as tin copper with no issues. Then you've got silver coatings. Generally, we use these for applications that are above 150 degrees Celsius. Again, each wire is individually silver coated. This becomes very useful when you start dealing with higher frequencies. There's certain electrical characteristics and qualities that play into this, like skin effect, that silver plating helps in that process. We also have nickel coatings. This is for extremely high temperatures. Generally, it requires special soldering guns due to the temperature and the temperature that the nickel coating flows at. Generally, you will crimp onto nickel-coated wires. We actually have heat guns or soldering irons that go up to the flow temperature, which is, I want to say, about 400 or 500 C to get that material flowing. Generally, you're going to use this, again, for silicones, fiberglass, either tape wraps or materials, and want to use it in high temp applications. So insulating materials. Now we talked about copper. Let's move into insulations. There is a number of factors that influence the selection of insulation, from physical properties to thermal properties. So specific gravity and weight. We manufacture neutral buoyant tethers. The specific gravity of the material becomes inherently important to ensure that we've got the lightest material on that cable so that we can keep that neutral or floating requirement. Spirometer is also a definite requirement when we're in CCTV or in kind of pipe inspection. We want to make sure that we have a hard durometer material so it can handle abrasion. Tensile elongation, abrasion cut-through resistance, chemical resistance is another one. And depending on the material, polyethylene is a good replacement to Teflon. Again, polyethylene doesn't handle benzene real well, but it does handle pretty much the remaining scope of what Teflon is good against. Well, one thing I'll note here is, if you can, polyethylene is about a tenth the price of Teflon. So really diving into what's my environment can play effect into how much cost is really put into the program. Radiation, and what kind of electrical properties. You also have thermal properties. What are my min-max operating temperatures? Am I going to be in negative 60 Celsius temperatures? Do I need solder iron resistance, right? This would be a choice between polyethylene or polypropylene. And then flame resistance, are there any kind of smoke propagation characteristics that I need to meet? So common insulation materials. There's a number of different thermoplastic materials. We're going to talk about some of the main materials that we use in cable and cable assemblies. First thing, PVC. This is going to be something that's more prevalent. It's starting to become less and less used because of the halogenations. When you look at it globally, there's an effort to push those materials out because of the halogens that are in that material. But we do tend to use some of these when we're looking at tray cables and a variety of different power constructions. We do have polyolefins of the ethylene family. This is an ethylene family, or the olefins. There's a number of different blends that you can get with polyolefins. Polyethylene and polypropylene are the two main materials. They've got very low dielectric constants, which for the engineers in the group, this is very important when you're looking at pairs, digital pairs, and different types of electrical impedances. They've got great chemical resistances. When you compare polyolefins to your fluorocarbons, they basically have the same type of chemical resistances. The only difference being fluorocarbons have a little bit wider branch of resistances, such as benzene, but polyolefins are a great substitute when you're looking at electrical requirements, chemical requirements, and possible replacements to Teflons. The next material is a fluorine family. It's going to be Teflons, which will be FEP, TFE, ETFE. Again, great chemical resistances, very low dielectric constants. When you look at the dielectric constant between polyolefin or polyethylene Teflons, Teflon have about a 2.10 dielectric constant. Your polyolefins will range in about 2.23. What this means is with that slight smaller or lower dielectric, you're able to get a little bit smaller profile in your pairs and your coaxes, which could mean the difference between being within a specification or being slightly out. So definitely you've got some alternatives there when you're looking at these two materials. Polyurethane is a great material. It is also, we use probably the most of it. Very good mechanical properties, very good chemical properties. It's just a good all-around durable material. We use this on molded materials as well as jacket and insulating materials. So a good all-round product. We do have our thermoplastic elastomers. These are our TPEs. These are part of the olefin family, so we want to be aware when using these materials there could be some adhesion concerns you want to be aware of. They are very difficult to mold to. but you do have a great temperature profile of -70 degrees Celsius all the way up to 125 degrees Celsius. So when you look at that temperature range and you compare that to some of the other thermoplastics, it's probably the widest temperature range that you can get in a thermoplastic. Because it is an olefin-based material, it has great chemical resistance properties. Generally, the durometers on these thermoplastic or TPE materials can range from 65 Sure A all the way up to 90 Sure A, which means it's a very flexible material. We also have nylons. These are very high resistance to abrasion, have a low coefficient of friction, which are great when you're pushing them down pipes or any kind of CCTV camera work. We use a lot of these in our CCTV market. Your cable jackets, you can pretty much use the same insulating materials on your cable jackets. There's two things to note for cable jackets and really insulation materials as a whole. You've got thermal sets and you have thermoplastics. Thermoplastics are what we reviewed. Thermoplastics are meltable, so you can heat them up, reflow those materials. Thermal sets, once they're in a pelletized form and you extrude it, that's the form it sets. You can no longer reuse those materials. Thermal sets generally have a little bit wider temperature profile. They also can handle a little bit, they can handle a different number of chemicals over a majority of the thermoplastics. When you look at Teflon, you look at polyethylene, they kind of have the largest chemical resistances in a thermoplastic, but overall thermal sets used in, those are going to be your neoprene rubbers, they're going to be your EPDM rubbers, and you're using those in underwater type applications or any kind of wide range of temperature profiles or temperature applications. Okay, cable assembly design, very similar to cable design. You want to look at your power requirements. You want to look at your certification requirements. You want to look at material compatibility, communication requirements, and mechanical requirements. Some things that you want to keep in mind when you're looking from a mechanical standpoint and you're looking at designing the cable assembly, you want to look at what kind of IP protection that you need. So it ranges from IP65 all the way up to IP68. IP68 being the most rigorous, meaning it is protected against long periods of immersion under pressure. So these tend to be, when you look at the scale of cost, these tend to be a little bit more expensive because there's just more technology required when designing cable assemblies and connectors going into depth. One thing to be aware of on connectors is just because it's rated IP68 does not mean that it is able to handle all depths of pressure. So sometimes it's IP68 up to 10 meters for a week or 2 weeks. Sometimes it's indefinite and the pressures are limited to 5,000, 10,000 PSI. So look at that. Also, the molding types. There's specific mold types that can only handle IP68, and we'll review those. If you're looking at injection molding, which is kind of your standard type molding for topside, the mold adhesion between your jacket material and your mold material will handle up to IP67, which is 1 meter of depth over a certain, believe it's 1 hour. So your limiting factor on that would be your connector. So just, again, keep in mind when you're looking at if there's any kind of IP protection that you need, the higher the number, the more rigorous that requirement will be, and cost can be associated with that. Connectors. So there's a number of different connector manufacturers. We talked about the variety of connectors that's available out there. Something to be aware of, you've got your amps, your Deutsch, Seacon, Amphenol, Molex. When you're selecting a connector, again, I know it can be difficult depending on what kind of connector you're looking for, but try not to be sole sourced into one supplier. That'll help with your lead times. It'll keep your costs down, and overall just availability. When they're more readily available, they're generally will help you stay on task with your timelines. Again, Teledyne, we manufacture a number of connectors, our impulse line, our AGG line. These are all really specialized style connectors for depth and underwater applications. But again, when looking at connectors, just try to make sure to fit the connector with the application and look for available sources, more than one. Okay, molding capabilities. There's 4 different styles of molding in the industry. Cable Solutions is able to provide all 4. The first one being injection molding. This is the most prevalent of the molding styles. This is taking pelletized material, putting into a hopper, applying heat, and then you've got a shear force that ultimately melts the material and then pressurizes it and pushes it into a mold cavity. This type of bond is heat and pressure. Again, this process will give you IP67 protection from the cable to the mold, but your connector on the front end could be limiting, and it may not make that assembly IP67. Our next process is a 2-part epoxy molding. We use these in depth applications where you're going 5,000, 10,000 PSI. It basically takes 2 different parts of a polyurethane, puts them together. It heats, activates, then forms a chemical bond to the jacket material, which allows us to get to the depths of higher pressure ratings. We do mold these to plastic. We mold these to metal. So again, I use these mostly in our underwater type applications. We do have a vacuum assist molding, which is very similar to gravity fed, slightly different process though. We have a different 2-part epoxy compound that we put into a mold form for that. Then we actually apply a vacuum to the mold form to pull out all your champagne bubbles. So we're clear here, every single mold style that we've got our molding capability, they have air bubbles in the mold itself. The only one that would alleviate this is the vacuum assist molding. Where this becomes particularly useful, we manufacture cable assemblies for missiles, for fighter jets, and one particular assembly that we manufacture is for ejection seats on fighter jets. What happens is if you get air bubbles into the mold form, and you've got a 30 gauge wire, which typically you do with these type of assemblies, the aircraft vibrates at a high frequency, 20 kilohertz. What'll happen is if there's any air bubbles, that 30 gauge wire, if it has an air bubble across that wire, it will vibrate. It basically creates a void, so it will vibrate and break. The issue that you particularly run into is when the ejection seat has to fire off and the sequence is out of order because there's a wire that has been broken. If your ejection seat shoots off and your hatch does not breach, you have a devastating catastrophe. So it's extremely important when you have to have applications that the product cannot fail. We use these vacuum assist molding capabilities to be able to ensure really the integrity of the assembly and longevity of the assembly. The last capability is the heat transfer molding. That is mostly your neoprenes, your EPDMs. This is going to be a rubber mold form. This is good for chemical and different types of temperature requirements that are maybe needed for government use. This is going to be more as far as when you compare these in cost. Injection molding will probably be the cheapest. Heat transfer molding would be the next tier. Then you would have your gravity feed molding and then your vacuum assist molding. So if you're looking at cost, that's kind of how that rates. Heat transfer molding we generally use, again, for our underwater connectors, underwater applications because of the neoprene material and its ability to kind of withstand water. Okay, codes and standards. There's a number of different governing bodies that control not only cable, but cable assemblies. UL being the most prevalent, we use generally in cable manufacturing. So your UL, your tray cables, your any type of ULs required for the application, they're the governing body for that. We also have Canadian standards, which is very similar to are U.S. Underwriters Laboratory Organization, except they're in Canada. One of the things and one of the important aspects of regulatory agencies is when they certify a product, that product can be put into the field, and the OEM can have confidence that that cable or that assembly will work in that application without causing issues, fires, any kind of degradation to the system. So it's almost like an insurance policy when using ULs, or when you have cables or cable assemblies with the agency stamp on it. So essentially, again, it's more of a confidence for the end user when they have these ULs stamped on the product. You also have military specifications, NEC or National Electric Code requirements that assemblies could meet or cables could meet. And you've got your CEC, which is your Canadian Electric Code, which is the Canadian version of NEC. That concludes the presentation for today. If you've got any questions, please let me know. You've got my contact information on the last slide. Let me know if there's anything we can do to help you.
Bryan, thanks so much. That was really interesting. Very cool to see how much process is involved in this, and it was really neat to see that the products are being used on ventilators as well, which I didn't realize that. So good stuff.
Yeah. Awesome. All right.
All right. Well, hey, thank you so much. Really appreciate your time and your information. As Bryan said, his information is here. Please do feel free to reach out to him directly, and he'll be happy to help you out with any solutions that you might require. So everyone have a great day, and take care and stay safe. Thanks a lot, guys. Bye-bye.
Thanks, everybody.